our economics. So we're moving on to the final subject for today, and it is mathematics. And the topic is modular arithmetic. So let's watch this one, and when we come back, I'm going to be asking my final questions, and I'm going to be reading out messages on WhatsApp. So get ready and enjoy this.
We want to look at the concept of modular arithmetics. What are our objectives? Number 1, we should be able to define the concept of congruency or equivalence. Number 2, we should be able to perform basic operations on modular arithmetics. Number 3, we should be able to apply the concept of arithmetics, modular arithmetics, to our daily life. So how do we define congruency? We can simply define congruency as going around in a circle. And a very good example to depict that is our clock. It reads from 12 to 12, or mathematically we say from 0 to 0. When it goes round and gets to 13, we read it as what? 1 p.m. If it is at 17, we read it at what? 5 p.m. If it reads up to 25 hours, we still call it what? 1 a.m. So as a result, mathematically, we say 13 is equivalent or congruent to 1 modulo 12. 12 is equivalent to 0 mod 12. 17 is equivalent to 5 modulo 12. In fact, if you have 37, what you just need to do is divide by 12, and you have 1. So 37 is equivalent to what? 1 modulo 12. We can also look at the example of modulo 10. In modulo 10, we say that what? 4 is congruent to what? 14 modulo 10. The same thing for 24, 34, 104. They are all equivalent to what? 4 modulo 10. So meaning that in modular arithmetics, we have integers as our numbers, these values, and it must range between 0 and n minus 1, where n is the modulo we are considering. Now let's look at how do we add, subtract, multiply, and divide in modular arithmetics. If you are performing all these operations, we just need to perform operation and at the end divide it by the modulo we are in. So the remainder is what we are going to write down. So let's look at this. Evaluate 19 plus 23 plus 15 in modulo 12. When you add that, you get 57. If you divide 57 by 12, we realize that we get the remainder will be 9 modulo 12. What if you have 4, evaluate 4 minus 3 minus 2 in modulo 5. If you do that, you realize that we have minus 1 as our answer. So, but negative number can't be in modular arithmetics. So you add the modulo to it. So minus 1 plus 5 will give us 4. If you have, so it means 4 minus 3 minus 2 is what? 4 modulo 5. We may also have evaluate 4 divided by 5 in modulo 7. So if you do that, 4 is not divisible by 5. So you continue to add the modulo number to 4 until you get a number divisible by 5. So 4 plus 7 will give us 11. 11 is not divisible. Add 7 to it again, we have 18. It's not divisible. Add 25 to it, we add 7 to it again, we have 25. So 25 is divisible by 5. 25 divided by 5 is 5 modulo 7. We may also have multiplication and so on. So let's talk about the application. In the application, we may say if today is Thursday, on what day of the week is the next 100 days? So what you just need to do there is what? Divide, since we know that we have 7 days in a week, divide 100 by 7. Realize that the remainder is 2. Then add 2 to Thursday, 2 days to Thursday. That will be, it means you're adding Friday and Saturday. So the answer is Saturday. The next 100 days is Saturday if today is Tuesday. We also have that if today is Thursday, on what day is the next, what day of the week is the next 1,000 days? So 1,000 days, you may find it very difficult. Just split it in a way that you can divide by 7. The same thing as 700 plus 280 plus 20 divided by 7. 700 and 280 are divisible by 7. So just go to 20. 20 divided by 7. It means we have remainder 6. So add 6 days to Thursday. It means the next 1,000 days is Wednesday if today is Thursday. So in the next class, we'll look at how do we use this concept to solve why questions, the past question. So thank you very much for listening. Good day once again. I'm Abiona Kamaldin. So we want to look at how we can apply the principle of modular arithmetics to solve some questions in WAEC. So I have some questions here. Question number 1, it is May, June 2014, question 1 objective. Question says, in what modulus is it true that 9 plus 8 is equivalent to 5? So what you just need to do is add 9 and 8 together to give us 17. So 17, what can you use to divide 17 such that the remainder will be 5? And such a particular number like that is 12. Another way you can also do it, just subtract 17 minus 5 to give us 12. So option B is correct. Question 2, May, June 2015, question number 10 objective. Question says, if x is such that x is between 2 and 18, both are not inclusive, x is an integer, and x plus 7 is equivalent to 4 modulo 9. Find the highest value of x. So what we just need to do here is write out all the values of x based on the condition stated. So it means x will start from 3, 4, 5 up to 17. So then secondly, you now solve the equation. The equation 7 plus x is equivalent to 4 modulo 9. When we solve that, we realize that we get x is equivalent to minus 3. But minus 3 is not within the range of values that is allowed. So you continue to add the multiples of 9 till you get the required answer. So when we add 9 to 3, minus 3, we have 6. Add 9 to 6, we have 15. Add 9 to 15, we have 24. So, but 24 is not within the range. So the value that is within the range that is at the highest there is 15. So option B is correct. Question number 3, May, June 2016. Question 39 objectives. Question says, if 20 modulo 9 is equivalent to y modulo 6, find y. So what we just need to do here is 20 modulo 9. If you reduce it, we have 2 modulo 9. So 2 modulo 9. Now when you compare 2 modulo 9 with y modulo 6, we realize that in this case, you can compare directly our y equals to 2. Since 2 is even less than 6. So you can say that our y equals to 2. So the next question number 4. It is May, June 2018, question 37. That question says that what? It says that 3x is equivalent to 4 in modulo, 3x is equivalent to 4 in modulo 5. So let's find the least value of x. So how do we do that? To do that, we say that it's obvious that 4 is not divisible by 3 if you have to divide both sides by 3 there. So you continue to add the multiples of 5 to it until you get the required one. So luckily, if you add the first one, 4 plus 5, it will give us 9. So if you divide, x is equal to 3. Option C is right. Question number 5. So May, June 2019, question 5 objective. So if 7 plus y is equivalent to 4 modulo 8, find the least value of y within the range of 10 and 30. So if you have to solve that equation, we have what? Y to be equals to minus 3. It's equivalent to minus 3 modulo 8. So if you continue, but it's not within the range that they have given us. So add multiples of 8. If you add first 8, you have 5. If you add second 8, you have 13. If you have another 8, you have 21. So if you add another one, you have 29. But we are looking for the least value between 10 and 30. So we realize that 13 is the correct answer for that one. So option B. Then another question that we have is also May, June 2017, question 4 objective. It says that we have tables there. So in the table, we are asked to use the table to find the value of n, which satisfies the equation that we have there. The equation is n modulo 4, multiplication modulo 4 in bracket, addition modulo 3, addition modulo plus 3 equals to 0. So in our next segment, we are going to consider that one. Thank you very much. Good day once again. I'm Abiona Kamaldin. In continuation of the last question we're trying to solve, that was 2017 question number 4 objective. Said we should use the tables to solve the equation n multiplication modulo by 4 addition modulo 3 equals 0. So in that case, we'll first look at it. What addition modulo 3 in the table of addition modulo will give us 0. So it means our column will check 3 under 3. Where can we get 0? We realize that it is 2 under 2. 2 addition 2 plus 3 will give us 0. So if you compare 2 plus 3 give us 0. Realize that we have 3, 3. So from there, from the comparison, we have that n multiplication multiplied by 4 will give us 2. So you go to table of multiplication 2 and you check what multiplied by 4 will give us 2. What multiplied by 4 will give us 2. From there, you can see that 3 multiplied by 4 will give us 2. 3 multiplied by 4 will give us 2. So from comparison again, we realize that n equals to 3. That's option C. The next question is 2014, question 8a. It says, copy and complete the following table for multiplication modulo 11. So we have 1, 5, 9, and 10 as the values of x. So and they have given us the values for row 1 and column 1. So they want you to do the remaining one. So you start. 5 multiplied by 5 will give us 25. So 25 in modulo 11 will give us remainder 2, remainder 3. So it means the answer is what? 3 there. 5 multiplied by 5 will give us 3. The next one, 5 multiplied by 9, that's 45. But when you convert it, the remainder will be 1. The next one, 5 multiplied by 10, that's 50. 50 divided by 11, the remainder will be 6. Next one, 9 multiplied by 5 is what? 45. When you divide that, the remainder will be 1. 9 times 9, 81. If you do that, the remainder will be 4. 9 times 10, 90. If you divide by 11, the remainder will be 2. 10 times 5 is what? 50. When you do that, the remainder is 6. You do the same thing for 10 times 9, that's 90. That's remainder is 2. Do that for 10 times 10, that's 100. The remainder for that one is 1. So the table is ready. From there, they say use the table to evaluate 9 multiplied by 5, also multiplied by 10 multiplied by 10. Using board mass, you do the ones inside the bracket first. So 9 multiplied by 5, you can see from the table, will give us 1. From the table again, if you check 10 multiplied by 10, it will also give us 1. So 1 multiplied by 1 will be equals to 1. So that's the answer, 1. The next question, we want to use it to find the truth set of 10 multiplied by m equals to 2. What is m? If you look at the table there, on what do we get that? 10 multiplied by what? Will give us 2. Under 10, you see, it will be 10 multiplied by 9. So by comparison, m equals to 9. We do the same thing for the last question. That's n multiplied by n. Find n such that n multiplied by n equals to 4. In that case, we realize that what? Our n will be 9 because it is 9 multiplied by 9 that will give us 4. Thank you very much. Have a nice time.
right, so welcome back. It's still TV lesson SS3, and I am still here. My name is Adewo, and if you're just joining us, you've missed 2 lectures already, even 3. I don't know where have you been, but my questions are out already, and I'm going to be dropping you the last question so that we can start sending in our WhatsApp messages, because this is the time I get to find my star students. Okay, we just saw mathematics, and the topic was modular arithmetic. Now, the question is this, and I need you to listen attentively. Now, which of the following statements are true? Which of the following statements are true? A. 27 mod 8 is congruent to 3 mod 8. That's A. 27 mod 8 is congruent to 3 mod 8. B. 87 mod 23 is congruent to 18 mod 23. C. 14 mod 3 is congruent to 2 and 2 mod 3. And D. All these statements are correct. Now, these are the options. You need to tell me which of these statements